This is our third video in our series of lessons on thermodynamics. This video lesson is going to be focusing on how to read thermodynamic tables, and more specifically, this one is a saturated table, and we're also going to be working with superheated tables later in the video. Now, as you can see, this is a table for saturated ammonia, and that just means it's ammonia is within the vapor dome within this for all these values. In our last video we worked with saturated ammonia, so hopefully you can see some similarities between the values we used in that video and the values I'm going to be working with in this video. So for instance, let's say I wanted to look at what ammonia is, what saturated ammonia is at 50 degrees Celsius. Well, I'll just scroll down to 50 degrees. And it says its pressure is 2033.1 kilopascals. So that means because of the constant pressure line, constant temperature line in a PV diagram, we know that the pressure is always going to stay the same so long as the temperature is stays constant. So whenever we have saturated ammonia at 50 degrees Celsius, the pressure is going to be 2033.1 kilopascals, always. And then to the right, we have specific volume. This is V sub F, that's for in its liquid state. V sub G is its vapor state. So this is the specific volume for the vapor, 0.06337 meters cubed per kilogram, and its liquid state is 0.001777 meters cubed per kilogram. And these values should seem a little familiar because they are the same two values we used for Vg and Vf as I used in the last video. So if I were to give you a quality, like let's just use 0.8, the quality that I used in that video, and I wanted to find out the specific volume, I just used the formula we figured out to be 0.8 times Vg plus 0.2, because that's 1 minus the quality, times Vf. And that would give us the specific volume at 50 degrees Celsius for a quality of 0.8. So as you can see, you're going to have to know its quality or be given something other than temperature or pressure to find out something about, to figure out all the rest of the thermodynamic properties. If I were to give you a specific volume and a temperature, you can figure out the quality just by solving for it in the equation that I gave you. So, and for internal energy, enthalpy, and entropy, we solve for those values the same way we solve for a specific volume. It's just going to be the quality times the whatever we're looking for is gaseous phase, plus it's 1 minus the quality times its liquid state. Exactly the same method, nothing special, it's just that. And that's more or less it. It's the same thing that we do with specific volume over, again, 3 times. Now, you may not know what internal energy, enthalpy, or entropy is. Don't worry, we're going to get to them soon enough. So just don't worry. And now we're going to go on to superheated tables. Now, sorry, I did not prepare this out of the bat, so we're going to have to find it. I just clicked the tables icon so I can see all these other tables on this website. And we're looking for ammonia. Before we were using the T saturation table, so now we're going to look for the superheated table, which is right here. And this is the superheated table for ammonia. So as you can see, there are actually several mini tables each divided up by different pressures, and it goes all the way from 0.05 megapascals all the way up to 20 megapascals. So we have specific volume, we have enthalpy, and we have entropy. Internal energy isn't listed here. There is still a value for internal energy, but I guess this table didn't feel that it's important enough to include it into this table. I have seen superheated tables that included internal energy. So let's just find something. I want to know the enthalpy of ammonia, given that it's at a pressure of 1 megapascal and it has a temperature of 100 degrees Celsius. So first thing I'm going to do is find the pressure table for it at 1 megapascal. So scrolling, looking for 1 megapascal, and I just found it right here. Then I'm just going to go down to 100 degrees Celsius, and then here we go, enthalpy. It is going to be 1,664.3 kilojoules per kilogram. Very simple. And then same thing if I wanted to find specific volume or entropy. One more thing, one more thing about these tables is it also shows you what a T sub SAT for each table. Now what that is the saturation temperature. And what the saturation temperature is that's the temperature at which ammonia goes from being saturated to being superheated. So this is the threshold that it has to overcome to be classified as superheated. So anything below this threshold, ammonia is going to be within the vapor dome. Anything above it, it's going to be a superheated gas. So that's what this little SAT is right here. Just substitute the SAT with whatever the saturation temperature is for each table. So for this first table, it's going to be 24.9. And for this next table, it's going to be 30.94 degrees Celsius. And so on and so forth. Now, reading these tables really isn't that difficult, but it's a skill that you really need to master early on because it's something that's you're going to be doing throughout the rest of this class. So be sure you get it down. If you don't understand it, please watch it again. I'm going to include a couple practice problems that will be linked somewhere on the screen. Look for it. And that's it. So until next time, good luck with thermodynamics.